Okay.
Okay, could you tell me about what your goals are and what you hope to get out of these sessions?
I would like to know some basic knowledge of coding, just to expand my knowledge.
Okay, sounds good. All right, so to get started, I'm going to send you a link. This link is what lets you program on the web browser. Could you open that link and share your screen with me? And it's fine if you want to just share that one tab.
Hold on, You emailed it, is it?
No, no, I sent it on Zoom chat.
Oh, Zoom chat. Okay. Hold up. Okay. Uh, all right, and I'll have to share my screen, right? Okay, hold on.
Yes, and you could share the one specific tab if you like.
All right. Did you see it?
Yes, but could you zoom in a few times?
Zoom in. Okay,
Yes,
hold on,
that's a control plus.
Control. Oh wait, oh no, I'm on the wrong tab. Hold on. Control. Hmm, doesn't seem to be working.
How about control
Oh,
shift plus?
wait. Oh no, because I'm using Brave, so I don't know if that makes a difference. Because I'm not using
Wow.
Google Chrome. Yeah.
Okay.
Oh wait. I got it. All right.
Wait,
Can
what's
you
the
see it
key?
being zoomed?
Yeah, I can.
Control mouse wheel.
Oh, yeah, yeah. Okay, interesting.
Yep.
All right.
Yep.
Oh, yeah, that's fine. Okay. So there are two windows in front of us. I would like you to click on the window on the left.
Window on the left. All right.
Yes, and now I'd like you to add two numbers.
Okay. Any number.
Yes, any number.
Okay. Two and one. Is that okay?
Yeah, but now I would like you to add them.
Or add like then I add like 21, 21 like this.
Sure, yeah, perfect. All right, let's
Okay.
run it. So there's a blue button, run. Let's click on that.
Okay.
Okay, so what's happening here?
Must have white space separating it from its operands.
Hmm.
I don't know. There's no space. I guess I need to have a space. Is it
Yes,
like
yeah,
this?
yes.
Oh, sweet.
Perfect.
Okay.
Okay, so congratulations, that's your first program.
All right. Nice.
Okay. So programming is like using a calculator, which is not surprising because a calculator is a computer.
Hmm.
Can we add a third number in there? Great. Okay. Can we change one of the plus sign to a minus?
Right. Sorry. Minus run. Yeah. Hey, operations are the same group level at parentheses. Oh. So how do I do it? I need to parentheses. Is this correct?
Maybe. Let's run it.
You may need to add and remove some text. Okay.
The highlighted parentheses, is that meant to be there?
Oh, it's not.
Perfect.
Oh, okay.
Okay. So are you familiar with bandmass from mathematics?
Nope.
Okay, so in mathematics, there's a convention to order of operations. For example, we should multiply before we add.
Mm-hmm.
Okay, that does not exist here. There is no conventions for order of operations.
Okay. Oh
So,
yeah. I remember now. Bot mass. Yep.
yeah. So what was happening just now was that the computer, it saw plus and minus, but it didn't know which one to do first. So it asked you to specify which one to do first by adding parentheses around it. So in this case, we want to add first, and so we put parentheses around the plot, 21 plus 21. Okay?
Mm-hmm. Mm-hmm.
Okay. So, and the reason why there isn't a convention for order of operations is because in programming, there is a lot more symbols. In real life, we had bot mass is 6 letters, but in programming, it would have been like 20 letters. or more. Um, some programming languages do require you to memorize some convention, and it's very painful. This language is designed for beginners, and so they don't want you to feel pain. So there's no convention to memorize. Instead, you must be specific by adding extra parentheses. Okay?
All right.
All right. So far we've been exploring a bit of the laws of arithmetic. Let's try something a bit different. Could you delete everything? And
Delete it.
oh, yep. I'd like you to write two numbers separated by a comma.
Okay. Do I need to space it?
You don't have to, but you can if you like.
That's all right. I won't do it then.
And then I would like you to surround them in parentheses.
Both numbers or is
Yes,
like this,
everything.
like a group. Like a
Perfect. Yeah,
group.
that's
Like this?
perfect. Now,
Okay.
before the first parentheses, I would like you to write the following. NUM
NUM
dash MIN.
NIM
No, MIN. M for Marvin.
or MIM.
Last letter is N. N for...
Okay,
Yes, perfect.
okay. Min. All right, all right.
Yes. Now, before we run this, what do you think is going to happen?
Number I don't know, we'll take the lowest number and make it a negative. I don't know.
Interesting. Okay. Let's run it and see what happens. 21.
Oh, okay, 21. Well, I was close. So it wasn't negative. It's just a lower number. All right.
Okay, so you think it's good. Okay, let's just make sure. Could we like change the
Uh,
numbers to test our hypothesis?
all right. What? Let's switch out this one. 20. There we
Great.
go.
Okay. So it seems right. Yes, so this is the minimum operation. It gets you the minimum number. So min for minimum.
Mhm,
Okay. So in theory, there could exist an infinity of mathematical operations, but there are only so few symbols that we can use. So at some point, we need to start using words like right in front of us. Num min. It's a word.
mhm,
Yes. So it's just like it's no different from plus and minus in a sense that it's taking two numbers and operating on them. In this case, it's getting the minimum.
mhm.
Okay. Can we add this whole thing to a number?
Sorry, add it.
Yes.
So you mean like this?
Oh no no. The plus sign should be outside the parentheses. So let's keep
Oh,
what we have and let's add the whole thing to a new number.
add it like this.
Yes. Exactly,
Okay,
yes.
okay. All right. 80. So it'll be 100. No, must have space. Oh, okay, my bad.
That's
All
okay.
right.
It happens.
100. All right.
Yes. So the same way we can subtract and add in the same line, we can perform the minimum operation and then add all on the same line.
Mm-hmm.
Uh, Notice how we didn't have to add parentheses because if you look carefully, there's already parentheses there.
Yep.
So there's no ambiguity. It's clear that the minimum operation, the 2120 is associated with minimum, and that should happen first.
Mm-hmm.
Now, we can actually move the plus 80 inside uh, the parentheses as well. For example, we can do 20 plus 80. Could we,
Need
and can we
80.
delete the plus 80 on the outside?
Okay.
And let's run
So
this.
it will be 21 then.
Yeah.
Okay.
Yeah. So in this case, the addition is happening first, right?
Okay. Yep.
Whereas when the plus 80 was on the outside, the addition was happening second.
Mm-hmm.
So back to the idea of order of operations. Yeah. And the reason why addition has to happen first here is because in order to compare the two numbers, we need to know what the numbers are.
Mm-hmm.
So it needs to see 20 plus 80. What's that? It's 100. Okay.
100. Yep.
Great, great. Okay. So far, again, we've been exploring the laws of arithmetic, and we're using this like a calculator. All right.
Mm-hmm.
So we're going to move forward in time a little bit, and we're going to explore a new idea in mathematics, and that's algebra.
Okay.
Let's delete everything. I'd like you to write x equals 1, new line, x.
New line.
Yes.
Like this.
Yep. Perfect. Now, before we run this, what do you think is going to happen?
Uh, X will be 1, will become 1, I guess.
Okay, let's run it. Great. Yeah.
Yeah.
So it's variable substitution, right? So whenever we
Mm-hmm.
see x, we see 1. Okay.
Mm-hmm.
Um, okay, can we create a new line after line 2? So can we create an empty line between those two lines?
Okay.
And let's write x equals 2.
X equals 2.
Now, before we run this, what do you think is going to happen?
X will be 2 because you overwrite the first X.
Okay, that's a pretty good guess. Let's run it.
Oh, what? Okay.
Yes. So what's happening here?
Yeah, because it's conflict, same name. So it doesn't override.
It doesn't let you do it in the first place. Yeah.
Mm-hmm.
Okay. And if you the reason okay, so different programming languages will have different behaviors here. In some languages, you would be right. You would get 2.
Mm-hmm.
But in this language, you don't. Uh, One way to understand this is that whenever we use the equal sign, we're saying we're making a declaration. So we're declaring x as 1. So it's
Mm-hmm.
like, imagine we're mathematicians. We say, let x be 1, let x be 2,
Mm-hmm.
now x. So a mathematician looking at that will be thinking, wait, if you say x is 1, why would you say x is 2 now?
Mm-hmm.
Another way of thinking about this is like declaration. Let's say we declare independence. You don't declare
Mm-hmm.
independence again, right? You've already declared it.
Yep.
Okay, we'll re-explore this idea in the future. There is actually a way to change the value of x, but not like this. Okay.
Okay.
Now let's change x equals 2 to y equals 2. And let's change line 4 to x plus y. Cool, let's run it. Okay.
Aye.
So
Okay.
we can use more than one variables. Can we change y equals 2 to y equals x?
Y equals X.
Yes.
It will be 2.
Hmm.
Ah.
Okay, so variables can be assigned to variables, right? So what's actually
Mm-hmm.
happening is on line 3, when it sees y equals x, it's going to say, oh, what's x? Oh, it's 1. So y is 1. Great, so y is now 1. So that's what's
Mm-hmm.
happening. All right, so we've covered an important idea in algebra, which is the use of variables and the idea of variable substitution, that we can replace a letter with a number. All
Yep.
right. We're going to move on to another important idea in algebra, and that's functions. Um, Now, before we do that, what is a function?
Uh, a function. I don't know, something, it works an equation. I don't know. Yeah.
Okay, it's doing some kind of work. You're on the right track.
Yep.
Okay. Before I answer that question, let's actually just make a function right now. Can we delete everything? Okay. Let's write fun,
FUM.
n.
N.
Yeah, perfect. So
Oh,
notice how it's
fun.
bolded.
Oh,
So
yep.
it's fun for function. We're telling the programming language we are now writing a function. All right. Now,
Mm-hmm.
spacebar. So the first thing a function needs is it needs a name. Let's call ours f, just the letter f, which is commonly
Mm-hmm.
used in mathematics. Now, opening
Okay.
parentheses. The next thing a function needs is inputs. So let's say
Mm-hmm.
x. We call the input x. Okay, now
Mm-hmm.
closing parentheses, colon. Oh, that's a semicolon. We need a shift
Oh,
of that
sorry.
key.
Sorry.
Yeah,
Yep. Yep.
perfect.
Sorry.
Now, new line. Here we do what we want to do with that inputs. So let's say we want to add 1 to x. So can we do x plus 1? New
Oh,
line? Ah, you remember. Nice. Okay. New line. Now E and D.
E N.
N D. Yeah, so N. Oh, D for donkey.
Oh, D D or N. Okay. Okay.
Yes,
Okay.
N. Perfect. Okay. So what's happening here? So what is a function? A function is something that turns inputs into outputs. You give it
Mm-hmm.
something, it gives you back something. Okay.
Mm-hmm.
All right. So our function def. So what we hear is we have just defined a function.
Mm-hmm.
A function has three things. First, it has a name so that we can refer to it. Second, it has inputs. So x is an input. Okay.
Mm-hmm.
In programming, we don't call it an input, we call it a parameter. So we say function f has parameter x.
Mm-hmm.
You'll hear me use that word later. The third
Okay.
thing a function has is it has a body. A function needs to produce an output. How does it produce an output? It does work inside the body. So here, the
Mhm.
body is x plus 1. It calculates that, and whatever is the answer is the output. So a function has three things: a name, input or parameter, and an out and a
Mhm.
body. The body is used to produce the output.
Mhm.
The end, the n at the end there, that's used to denote the end of the body.
Okay.
Okay. All right, let's run it and see what happens.
Yeah, because X is not defined, right? So nothing
Uh,
happens, right?
oh, no, it's not because x isn't defined. Well, you're on the right track when you say that. It's more so that we
Oh,
didn't use the function. So
oh,
x doesn't have a chance to get any values in the first place.
okay.
So let's use the function. Could you create a new line in our program?
I still mean I don't delete this, right?
Yeah, don't delete anything. We need that.
Okay. Right.
So in mathematics, we say we apply a function, but in
Mm-hmm.
programming, we say we call a function. To call a function, first we must refer to it by its name. That's why the name is important. So first we write f, opening parentheses. Now any number.
Okay. 8.
8, great. Lucky number. Okay, let's closing
Yep.
parentheses. Okay, let's run it.
Oh.
Great.
Oh. Okay.
Okay, how did we get 9?
Yeah. 8. 8 plus 1.
Okay, and how did
Because
we get 8 plus 1?
yeah, because the X is I don't know the input is 8.
Okay, so the input is 8. And x
Yeah.
is sort of like a representative of the input. So x
Yep.
gets the value 8.
Yep.
Right? In that function, when we see x, we see 8, so 8 plus 1 is 9. Great.
Yep. Yep. Got it.
Okay, so this is another important idea in algebra, which is functions. So to summarize, we have covered numbers,
Mm-hmm.
arithmetic, and now a bit of algebra. Okay, so if we sort of have a pretty advanced calculator, but there's one more thing we can do on this calculator that's really cool. So notice how there are two windows here.
Yes.
There's a window on the left, which we have been writing in. This is our program. And the window on
Mm-hmm.
the right has been giving us answers.
Yep.
Okay, I want you to stay on the window on the right now. Notice how it's blinking. It looks like we can type stuff there. Could you
Yep.
call a function f with a different number now? But on the right side.
Oh, okay.
And now I want you to hit enter.
Enter.
Yes.
Oh.
Ah. Okay, let's play around with this. Could we call a function with any number and then add that to another function call? So f of something,
Oh, okay, okay.
and
Okay,
then let's
then
add
we
another number
add,
here.
is it F
Yes,
something as well?
exactly.
Okay. Enter.
Great. Okay.
Okay.
Can we now do f of and then a summation? So call f and inside the parentheses add two numbers.
Add two numbers. Okay.
Yeah,
You know what? 10 and 10, yeah. So that's
perfect. Yeah, let's hit
okay.
enter here. Great.
Hmm.
Okay, so remember nummin from just now?
Yes.
Nummin is a function.
Yep.
So the same way that we can add nummin, add like to the result of nummin, we can also add to the result of the function called to f. The same way we can do summations inside the parentheses of nummin, we can do summation inside the parentheses of f. Okay.
Okay.
Uh, so a bit of I owe you an explanation of like what's going on here. So the window on the
Mm-hmm.
left, we call this the definitions. This is we define our program here. We define things
Mm-hmm.
like f. The window on the right, we call this the REPL. That's REPL. Uh,
REPL. Oh.
yes. You don't really have to
Uh,
notice, but yeah, when I say REPL, that's what I'm referring to. REPL, what
yep.
does it stand for? It stands R for read. So it reads what you write. So when you write f of 10 plus 10, it reads that. E
Okay.
for evaluate. When we say
Okay.
evaluate, it really means simplify. So
Mm-hmm.
f of 10 plus 10 simplifies to 21.
Mm.
Evaluate. Another way of understanding evaluate is it means to turn into a value. That's why that's the word value in evaluate. In a
Yep.
value is just anything that cannot be simplified further. So 21 is a value. You can't do anything more to 21.
Mm-hmm.
Okay. So that's evaluate. P for print. So once it reads what you write, evaluates it, it has an answer, it prints it out so we can see 21 with our eyes there. L for loop. Loop because it lets you repeat stuff again and again and again, right? We have written so many things here again and again and again.
Mhm.
So that's REPL. Okay, you don't really have to know this, but well, when I say REPL, you know what it means. Um, Not all languages have this. Um, this language is designed for beginners, and what's important for beginners is fast feedback. And so the people who created this language has this feature.
Mhm.
So in your free time, if you want to play around with stuff, I suggest that you use this and play around with it. Okay. So far we've been working with the mechanics of programming. We have numbers, we have variables, we have functions, but I wouldn't say we're really, really programming yet. That's one key idea I want to now introduce. Let's go back to the left window and let's delete everything. Okay, I want you to write the number 5 now and just run it.
Oh, okay.
Okay, write 5, we get back 5. No
Yep.
surprises there.
Mhm.
Okay. Now, let me ask you, what does 5 mean?
What does five? It's a
Mean.
number.
It's a number. Okay. Now, what if I say, how about what is 5 degrees Celsius?
The temperature.
Temperature. Okay. How about 5 kilograms?
Weight.
Weight. Okay. Now, notice how they're all 5, but depending on whether I
Mhm.
say temperature or kilograms, that 5 means something a little bit different.
Yep.
So there are two worlds. There is the world of information. This is ideas and facts about our real world.
Mhm.
And there's the world of data. This is what the computer understands. So when I say 5 degrees Celsius, the computer only sees 5, the 5 right in front of us right now.
Mhm.
Okay? The computer does not know that's temperature. It only sees the number 5. That's
Mhm.
data. We think 5 degrees Celsius, that's information. Okay? Now, it sounds philosophical, but it's a very practical idea. Because I claim that our role as programmers is that we turn information into data, perform operations on the data, and convert data back into information. Now, we say that we encode information into data.
Mhm.
Encode. Another way you might hear this is we represent information as data. Let's represent. So here's an example. Let's say we have an electronic thermostat. So there's information like uh, how hot or how cold it is. This electro thermostat has physical sensors that picks up readings of its natural environment, things like electrical resistance or molecules in the air. So it has a bunch of numbers in its computer, and it's going to perform mathematical computations on those numbers and
Mhm.
deduce a single number. That resulting number is the temperature. Now, of course, the computer is not going to know it's the temperature. It just sees a number, but it's going to display it like 5 degrees Celsius. Now, we as the human, we can read it. Oh, it's 5 degrees Celsius right now. It's pretty cold. Okay. So the computer sees data, but we see information. Okay.
Mhm.
To reframe everything we have done so far, we have been encoding information as numbers and operating on numbers. I have another question for you. Can we encode all information as numbers?
No,
Why not?
because it's a one way street, so to speak.
What do you mean by that?
You go from what's that, numbers to information. You can't go back. You can't go in reverse. I don't know if you get what I mean. Like you can go from numbers to information, not information to numbers. I think.
I
I'm
mean,
I'm just guessing. Yeah.
that's a good guess, but for example, let's say 5 degrees Celsius, that's information,
Mm.
right? And
Yep. Yep.
we write that number 5 right in front of us. That 5
Yep.
is data. Didn't we
Yep.
just turn the information 5 degrees Celsius into the number 5?
Oh, so you can reverse it. I guess
So,
so. So you just remove the Celsius. Is that what you're saying?
yeah, like
Okay.
we have like the number, like we have information that's 5 degrees Celsius and we
Yep.
turn that into a number by removing degrees Celsius. Yeah.
Okay.
So back to my original question, can we encode all information as numbers?
Yeah. Yes. By that logic,
Why?
yes.
Why?
Yeah. Because we already have the number as a data inside the information.
How about information like, let's say my name, Marvin. That's
Okay.
information, right? Can we
Mm-hmm.
encode that as numbers?
If we define the letters, yeah, I think we can.
What do you mean by define the letters?
Like, I don't know, A is one, B is
Ah,
two,
okay.
C is three. Yeah.
Okay, that's actually how computers work, you know? Like
Mm-hmm.
we, I don't know if you heard of the word Unicode.
Unicode.
Yeah, have you heard of
No,
it? So when you
no.
type on your phone, like when you're texting someone, we actually use Unicode. Because when you text someone, you're transmitting bits over the wire, but the bits are zeros and ones, right? So there needs to
Okay.
be a
Okay.
convention as to how we convert bits back into letters. So
Mm-hmm.
you're actually correct. Yeah, we convert letters into numbers.
Okay.
In fact, it's not just letters. Our computers, have you heard that computers are just zeros and ones?
Yeah, binary, right?
Binary, yeah.
Mm.
Like when you download something on the internet, we say that like a game, for example, you're downloading a binary. It's just zeros and ones.
Mm-hmm. Mm-hmm.
So yes, we can encode all information as numbers. Now, next question. Do we want to encode all information as numbers?
Uh, uh, maybe, I don't know. Is it efficient or
Ah, efficiency. Yeah, that is a
yeah.
factor. For example, you and
Mm-hmm.
I talking right now, we are not talking in numbers.
Yep.
Yeah, like we're conveying information to each other, but we're not talking in numbers, right?
Yep.
Like we're not talking in Morse code. I mean, back in the days,
Mm-hmm.
people had to talk in Morse code. It was wildly
Mm-hmm.
inefficient. You know, you had to like tick, you have to hit a tick, 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 and you have to write words.
Yep. Yep.
And no, you have like a
Yep.
room full of people writing words because someone might make a
Yep.
mistake. So
Yep.
it's incredibly inefficient.
Mm-hmm.
Uh, so no, there are other ways of encoding information, like words.
Mm-hmm.
And the reason for that is efficiency. It's more understandable. It's more understandable to hear me speak in words than Morse code. Okay,
Mm-hmm.
so we have learned that we need more ways to represent information. We don't want to represent everything as numbers.
Mm-hmm.
And so we're going to do just that. I would like you to delete that five. I would like you to write double quotes.
Right, what? Double code?
Yes, double quotes. No, no, no. That's the key to the left of enter and shift. Yes,
Oh,
double
okay,
quotes.
okay, okay. Double
Inside double
quotes. All right.
quotes, I would like you to write hello, comma space world.
Inside.
Yes.
Hello space. Oh,
Oh no,
hello
it's like
space
comma.
world.
No,
Yeah,
no,
yeah, yeah.
comma.
Sorry.
But you
Oh,
must add a
hello.
comma. Comma
Hello space. No, comma space
space
world.
world. I explain why the comma is important, but yeah, let's run this.
Okay.
Hello world.
Yep.
Okay, so two things. First, we did not get back a number. We got back
Mm-hmm.
a different animal. We got
Mm-hmm.
back a string. We call that a string.
Right.
Why is it called
Okay.
a string? I think it's because it's a string of characters or something.
Yep. Mm-hmm.
So strings are used to encode textual or like textual information or like worded information. Okay, so
Mm-hmm.
that's the first thing. The second thing is why hello comma space world? You honestly could write anything. Honestly, you could also delete that comma. The comma is not important, but the reason why I asked you to write this specifically is a historical reason. Uh, in the 1970s, this is like the very early days of computing. Back then, there weren't many programmers. It was like a very rare thing to be a programmer. Now it's the opposite. Now it's everyone's a programmer. Now
Yeah.
programmers are being replaced, in fact. Wasn't the case back then. Anyway,
Mm-hmm.
so 1970s, there's a very established programmer. He wrote a book on how to program. And in this book, he used the example Hello World.
Mm-hmm.
Ever since that day, every book, video, lecture, every single learning source you could learn from, use this example Hello World. So this example is a rite of passage.
Okay.
So congratulations, you have reached a very important milestone in your life today. You can maybe do something later to celebrate, pop champagne or something. Okay, so
Thanks.
hello world. Okay, so our Zoom session is going to expire. So I'm going to close this one out and I'm going to send you a new link in Gmail, okay?
Okay.
All right. I'll see you in a minute. All right. So now we have moved beyond a calculator. We are you operating on things that aren't numbers. We're now operating on strings, right?
Mm-hmm.
Okay. Just now we added two numbers. Could we now add two strings?
Ooh, where at?
Oh, let's go to the left window.
Okay. So it's the same, right?
Yeah. How do we add two numbers, right? So
Oh, do I just type anything?
oh yeah, any word you want. There's no restriction this time.
Okay.
Greetings. Perfect. Okay. Now let's add them together.
Um, add with hello world.
Yeah.
How do I go about that?
So how do we add two numbers just now?
B plus.
Plus. Okay,
Wait,
let's use it.
really?
Yeah.
Okay.
And let's delete the first line. Okay. Let's run it. Let's see what happens.
All right.
Nice.
Okay.
Greetings, hello
Greetings,
world. So the
greetings,
same way,
Shalom.
yeah, shallow. Yeah.
Yeah.
So the same way we could add two numbers, we could add two strings, right?
Mm-hmm.
So there's like a notion of arithmetic, but for strings.
Mm.
Could we replace the plus with a minus?
Oh,
Okay,
okay.
let's run it. Let's see what happens. Oh, what
That
happened?
doesn't work. Right
What?
side operator expects to be given two numbers. Oh.
Yeah, so subtraction only works with numbers. Doesn't make sense to subtract two strings. So
Hmm.
even though there's a notion of arithmetic for strings, what that means is fundamentally different from arithmetic for numbers.
Mm-hmm.
Okay, let's delete everything again. I'd like you to now write double quotes and then five.
Wait, like the five inside the code, right?
Yes, yes, yeah. Let's run this. Okay, nothing special, right? The same way we
Mm-hmm.
wrote hello world, got hello world back, we could write five in string and get five in string back. Okay,
Mm-hmm.
could you now, on a new line in our program, write the number five but not in quotes? Let's run it. Okay, so we see five, one in quotes and one that isn't.
Mm-hmm.
I have a question for you. Now that we have strings, and strings are a series of characters, and to write a number, you have to write a series of characters. Why do we need numbers? Why not make everything strings?
I don't know, for the flexibility, I suppose.
What do you mean by flexibility?
I mean, you have more options, right, on how you write the strings. I mean, if you will be restricting yourself if you exclude numbers.
So what I'm saying is, why not just use
Yeah.
strings for everything, right? As you say, strings are very flexible. We can have numbers in strings.
Oh, I see. Why use numbers? I guess it depends on what you want to do, right? Sometimes you don't need a string. Just numbers is good enough, depending on your objective.
Okay, so what's an example of an objective where we want numbers but not strings?
Like a mathematical equation and
Hmm.
function, I guess. Can you use strings for function? Oh, maybe you
We can
can, huh?
actually. We can.
Oh, okay. Yeah,
I
then
don't know
for
if we'll have
equations
time.
then
Yeah.
yeah.
No, no, no. Yeah, I get what you mean. Okay.
Okay.
Uh, yeah. For example, we can subtract two numbers, but we can't subtract two strings, right?
Ah, true, true.
So they have different operations. We can do different things with them.
Mm-hmm.
So while the same piece of information can be represented with multiple data types, there are strengths and weaknesses to each data type. Oh,
Mm-hmm.
when I say data type, I mean a classification of data. So like a number is a data type, a string is a data type.
Mm-hmm.
Yeah. Okay, great. So to summarize, we have covered numbers and strings, and we can perform arithmetic with each one.
Mm-hmm.
Uh, you know, now that you say functions and strings, I kind of want to do that now. I don't usually do this in the first session, but we might as well. I would like you to know to
Okay.
create a function.
All right.
Okay, do you remember how to create a function?
Yep.
You need a keyword. What's the keyword to write a function?
Oh yeah, sorry. Fun. My bad, my bad.
No, it's all good. FUN. Great, great. I want you to call this function greet. That's GREET.
Uh GRET.
EET. Great. Now, but I want the greet to come before the parentheses.
Oh,
Yes. Okay. Yes. Now opening parentheses. I would like this greet to take in a variable called name.
Name.
Yes. Now closing parentheses, colon. Um, yeah, colon.
I know,
That's a
sorry.
semicolon, colon.
Yep,
Great.
yep.
Okay. I want what I want this function to do. I want this function to say hello and then the name. All right. So if
I
I
need
pass
it needs to
in,
be in quotes, right? It needs to be in quotes, right?
yes, perfect. Yeah. And now I want
Hello?
to say hello and then the name. So, like for example, if we pass in Marvin to greet, it will say hello, Marvin.
No, so hello name, is it?
Yes. Okay. And how do we end a function?
The next line, END.
Great. Okay, let's run this. Okay, I would like you to, on a new line on our in our program, can you write greet and any string?
Read like this.
Great, yeah. But to remember, how do we call a function?
Oh, uh, wait. I think we need
So
to.
first we it's not f, it's actually called, remember, the f is just the name, right? But now the name of the function is greet.
I see.
Yeah,
So I need to do as like the same thing like this.
exactly, yes.
Okay.
Oh,
What?
doesn't know what mark is.
Oh, I thought we can just write anything. Oh, name. Wait, no, can't be, right? Is it like this?
No, it's not. It's not that.
Okay.
So, okay,
Okay.
so mark is information, right? It's
Uh-huh.
textual information. How do we encode textual information?
How we encode, I don't know, defining it with numbers. Is it?
No, no, no. Like just now, like we introduced Hello World.
Yep.
What's the first character I asked you to write before Hello World?
The double quotes,
Double
is it?
quotes, yes. So if you don't add the
Oh,
double quotes, the program will think it's a variable.
I
So
see.
what it's saying, the name mark is unbound. It is used but previously undefined, not previously defined. It's saying that, oh, I see a variable, but I don't see you defining this variable.
Mm-hmm. Mm-hmm.
That's why the string is important. Okay,
Okay.
so let's run it. So it
Hey,
says hello name, but I
yeah.
want it to say hello Mark, right? So how do we
Yep.
fix
Yep.
this?
Uh, hello. Name equals mark. Can't be, right? Like this?
Okay, let's run it. Let's see what happens.
No, it's wrong.
Okay, but notice how nothing changed. We're still getting hello
Yep.
name.
Yep.
Why are we always getting the same thing, hello name?
Because the function is just greet bracket name, right?
And what's the body? Remember, the body is what produces the output.
The body, uh, hello name.
Yeah, the body's hello name.
Mm-hmm.
It's literally the string hello name, right?
Yep. Yep.
The body is the output. That's the body is literally what you're getting back.
Mm-hmm. Mm-hmm.
But the okay, just to simplify things, in the string hello name, could you delete that name in the string?
Delete the name.
Yeah, yeah. Because I'm gonna what I'm saying might be confusing if that's still there. Okay, what I'm gonna say now is that's the parameter name, right?
Okay. Yes.
We should use that somehow, right?
Yep.
How do we use that?
Um, I don't know, defining the name. I don't know. Yeah.
Like remember just now when we had f of x, x plus one,
Yes.
we added
Yes.
one to x.
Yes. Yes.
What do we want to do with name here? This variable name.
But the thing is, because there can be many different names, right? So I'm not quite
Yes.
sure. Yeah.
Remember, like just now, f of x, x plus one, that could be many different x. We still added one
Yes.
to it.
Yes. Yes. Yes.
So how do we do that? What does that mean in this context?
Uh, but the name is letters, right? So you add strings to it, is it?
Oh, add strings. Oh, that sounds familiar.
Uh-huh.
How do we add strings?
Uh, name, right? Right?
Okay, keep going.
But does it work? I feel like it's not going to work though.
Okay, so it's not you're on the right track, but Notice how you
What?
keep writing name inside double quotes?
Yep.
When you do that, it's going to be literally name in double, like it would give you name, like not the person's name. It will actually be NAME.
Oh, okay.
Should name be in
Mhm.
double quotes?
So name plus mark, is it?
Close, but okay. Okay, firstly, let's move. Okay, let's delete line 4. The name, right, should be actually be written in line 2 inside the function. In fact, just for clarity, could you put hello onto a new line?
Oh, okay.
Like between line 2 and 3, sandwich between fun and an.
Like this.
Yeah, perfect. Okay, so name should be on line 3 somewhere.
Line three.
Yes. Name should be in here and not in quotes. Okay, so we have two things now. We have name, the parameter, and we have hello in string. What do we do with these two? How do we get hello name at the end?
We just switch out this.
Okay. Is that it?
Yeah. Yeah. Or do I need to define name?
No, no, name is already defined. Name is the input.
Oh, okay.
Yeah.
Oh, like read like this,
Oh, wait, no, the
right?
mark has to be in string. Remember what happened when mark
Oh, it
wasn't in
has to be a
string?
string. Oh, yeah,
Yeah.
that's true. Okay,
Okay,
okay.
well, let's run it. Let's see what happens.
Okay. Oh, shoot. Sorry. All right. No.
It's very close, I'll tell you that.
Really? Hidden
It's
block
very close.
isn't intentional. What?
Okay, so here's
Space,
what's
is it?
okay. What we have here, right? Remember just now
Hmm.
I said like we had two strings, we were able to add them together.
Mm-hmm.
How do we add two strings together?
Yeah, the quotes and then we plus, right?
Plus, okay, great. Let's run it.
Oh. Oh. Oh, but there's no space.
How do
Okay.
we add the space?
I don't know, like double quote. Is it?
Uh,
Oh
that's the
no,
same
no.
problem as before.
Wait,
Remember how?
quote space.
Sure, sure.
Oh
Don't
no, it
forget.
doesn't work as well.
No, no, it's not working because you got to add white space around the plus sign.
Oh.
That's still not going to work. Same
What?
problem as
Oh,
before.
oh
We have two
wait,
strings.
wait,
How do we add
wait.
them?
Like
Great.
this.
Perfect.
Okay. Right,
Perfect.
right.
Yeah. And you can greet other people as well. Let's call greet again on something else. Johnny, okay. Hello, Johnny.
Yeah,
So
yep.
this is actually not too far off from our real world examples. So I don't have this set up right now, but notice how I've been sending you all emails.
You've been sending me emails.
No, like, oh, I don't know.
Oh,
Okay, I don't know. Okay, if you're asking me that, that means you haven't been getting my email. So on my
uh,
Gmail, I send people emails. Like I say, hi, here's an update, whatever.
okay, okay.
But I could also say like hi, like okay, it's like hi Marcus, right? I can like say your
Yep,
name.
yep.
How do I do that programmatically? What I can do is I find out what's the name of the person I'm sending an email to, and I substitute their name.
Mm,
How do I substitute their name? Something like this.
okay.
Like I pass the person's name into a function like send email, and it will substitute their name.
I see. For everything inside,
Yeah.
all
Like
their names inside within the
like
email.
in video games like Final Fantasy, at the start of the game you can write your name, right?
Yes,
And
yes.
throughout the game they'll call you by that name.
Yep.
Okay, that doesn't happen
Oh,
by a function, but that happens by the same idea. The idea that we are assigning a value to your name. So that like the name is Johnny. We're assigning that value, and throughout the game, it will look at the variable. It's like, oh, the variable name. What is it? Oh, it's Johnny. Okay, so we'll call them by Johnny, right?
yep. Got it.
So all this is to say that the same ideas of arithmetic and algebra applies to strings.
Mm-hmm.
So we're well beyond the calculator here. And this a power to apply arithmetic and algebra to strings is what gives programming its power. That's why we can do so many amazing things.
Mm-hmm.
Okay, we have 13 more minutes. I'm going to introduce a third data type. So let's delete everything. So we've covered numbers and strings. I'm now going to introduce this third data type. A data type is usually used to encode information, and they tend to be very fundamental or important. Like numbers are used to encode like mathematical things. Numbers, strings are used to encode textual information, words. Language is very important to humanity, right? Now, this third data type is going to be used to encode decisions. Decisions are important. It can be said that life is a series of decisions. Like, for example, your decision to come to this office hours, you must have said yes. A decision is fundamentally either a yes or a no. Um, so like this, like yes or no, or a light switch, on or off, true or false. This idea of duality between two things, in programming, we call these Booleans, named after a person named George Boole, who studied these things as mathematical objects. And in
Mm-hmm.
programming, we refer to them as true and false. Could you write true? That's TRUE, all lowercase. And let's run it. So again, we got back a different animal. We didn't get back a number. We didn't get back a string. If it was a string, it would have double quotes. We just got back true.
Yep.
Let's notice the true is red in color as well in the editor. So
Mm-hmm.
special. Let's replace the true with false. That's FALSE or lowercase.
Yep.
Great. Again, red in color, got back false.
Mm-hmm.
So
Mm-hmm.
numbers, right? Numbers we can say there's 1, 2, 3, 4, 5, 6, and go on to infinity. There are a lot of numbers. Strings,
Mm-hmm.
so many strings you could write. You can say hello, world, blue, Johnny, Mark. You can
Mm-hmm.
say so many things. But Booleans, there's only two. That's true and false. These two things, right? All right, so the same way that we could perform arithmetic on numbers and strings, we could perform arithmetic on Booleans. Let's write false and true. That's false, A and D, all lowercase, and then
Is
true.
it?
Yes, perfect. Let's run it.
Wait.
False and true
That's
is
all.
false. Notice the and is bolded, so it's
Yep.
special.
Yep.
Can we replace the and with or? That's OR. Okay, let's run it.
Oh.
Cool, cool. Okay. So the same way, we have like two booleans. We have an operator in the middle that combines them into one boolean.
Mm-hmm.
So these bolded terms are called Boolean operators. They operate on
Mm-hmm.
Booleans. The same way we have
Mm-hmm.
arithmetic for numbers and strings, we have arithmetic for Booleans.
Mm-hmm.
Great. Okay. So I'm gonna share my screen real quick. I'm gonna show you something.
Okay.
Give me 1 second as I set this up.
I don't have to stop sharing, right?
You might have to. I've
Oh,
I've heard
okay.
mixed reports on this.
Okay, then I stopped. Yeah, I stopped
Yeah, okay.
sharing.
Give me 1 second to set this up. Okay. Let me know once you see my screen.
Yep, I see it.
Okay, so here
Oh.
we have this looks a lot like a lot of things. It looks daunting, but it's
Yes.
actually not very daunting. So let me explain what's happening here. Each table, or each one of these, there's a word, there's a picture, and there's a table. So this
Mm-hmm.
table, we call this a truth table. Um,
Mm-hmm.
Another way of understanding Booleans is that they encode truth, whether or not something is true.
Mm-hmm.
0 is false and 1 is true. Remember how
Mm-hmm.
I said that computers are a bunch of zeros and ones?
Yep.
These are the zeros and ones. These are
Mm-hmm.
it. Each table tells us how we can go from 0 and 1 to a 0 or 1. So
Mm-hmm.
for example, we saw false and true is false. So this is the AND operator. False and
Yep.
true is false. So that's the answer here. For the
Okay.
OR operator, false or true is true.
Yep.
Okay.
Yep. Got it.
So what are these? The simple answer is these are the definitions for Boolean operators. This is what defines arithmetic for Booleans.
Mm-hmm.
Okay. Um, but why is AND doing that and why is OR doing that? Like why these answers specifically?
Mm-hmm.
Here's the easy way to understand it. If you have a banana and I say, do you have an apple and a banana? And you say, oh no, I only have a banana. You say, no, I don't have an apple and banana. So it's false.
Mm-hmm.
But for or, if you have a banana and I say, do you have an apple or a banana?
Or
You
a
say,
banana.
yes, I have a banana,
Mm-hmm.
right? So one way to understand this is in N, if at least one of the terms is false, the result is
Mm-hmm.
false. So notice
Mm-hmm.
how if the row has zero, the result is zero.
Yep. Yep.
For or, if at least one of the term is one, if one of the term is true, then the result is true.
Mm-hmm.
So that's the easy way to understand these two operators, and that's the intuitive explanation for how they got their name. There's
Yep.
another operator that you commonly hear, and that's not. It just flips the Boolean. If it's false, it's true. If it's true, it becomes false.
Mm-hmm.
As programmers, we only need to think about these three Boolean operators. The
Okay.
rest, you might see them in other programming languages. If you're an
Mm-hmm.
electrical engineer, you might have to think about them. If you're into cybersecurity or low-level programming, where you have to write very performant algorithms, you have to think about them.
Mm-hmm.
Otherwise, we think about not and an or.
Okay.
Conceptually, Boolean operators are like functions. Functions in the sense that they have inputs and outputs, like
Mm-hmm.
input and output. All right.
Mm-hmm.
Okay. But what are these pictures over here? These are logic gates. Well, drawings of logic gates. These are physical devices that physically embody these Boolean operators. They
Mm-hmm.
are literally objects, like things you can touch, and there are wires
Mm-hmm.
going into them and coming out of them. Our computers are built by thousands, millions, billions, trillions of these things, of these tiny things.
Mm-hmm.
These wires may or may not have electricity flowing through them. So, for example, for the N, if one wire has electricity flowing through it and one wire doesn't, no electricity will flow on the other end. If a wire has electricity, it's a 1. If it doesn't, it's a 0. So our computers are a soup of zeros and ones, and you have these logic
Yep.
gates that are changing the zeros and ones, that are stirring this soup of zeros and ones. And
Mm-hmm.
this is what makes computation possible, right?
Yep. Understood.
Okay. You don't have to know that, by the way. Like you can completely forget these logic gates, but they're good to know.
Mm-hmm.
But
Mm-hmm.
all this is to say is that we have Boolean operators. We can perform arithmetic on Booleans, and Boolean operators, arithmetic on Booleans are defined by these things, these truth tables. As programmers, we
Mm-hmm.
only need to know about not and an or. Okay. I'm going to stop sharing my screen now, and I'd like you to share yours again. And while you
Okay.
do that, I'm just going to summarize. We have been working with three data types so far. We've worked with numbers, strings, and booleans.
Mm-hmm.
And we can do arithmetic for every single one of them. We
Mm-hmm.
can also do algebra for every single one of them. We can pass them into functions.
Mm-hmm.
Okay. Um, well, in our last 4 minutes, I want to close with one cool thing. I'm going to introduce a
Mm-hmm.
fourth data type. I'm going to type
Oh,
something in Zoom chat,
okay.
and I'd like you to copy it and paste it into the editor. Just replace what's there.
All right.
And don't run it
Mm.
yet.
But sorry, I don't know why
That's perfect. Now, before
all
we
right.
run it, what do you think is going to happen?
It's gonna be bolded and red in color and in circle. They're gonna circle the 30 with a solid red circle.
Okay, let's run it. Let's see what happens.
Oh, never mind. Okay, there's no
Ah,
number 30. Right.
so what is the number 30? Can we change the number and see what's happening?
It's the size of it, I guess. If pen, it will be smaller. There we go.
Yes, perfect.
Yeah.
Okay. All right. I'm gonna wrap it up here.
Mm,
So this is our fourth data type, images. A data type doesn't have to be fundamentally philosophical, doesn't need an
yep.
existential reason to exist.
Yep.
Sometimes data types are just useful. This language is designed for beginners, and many times beginners are children. And so we have images. They let them work with images. It's a lot more fun, very intuitive. So the same way
Mm-hmm.
that we can perform arithmetic on number strings and booleans, we can perform arithmetic on images. We can combine them in interesting ways. Uh, yeah, but we'll look into that for next time. So to
Right.
summarize what we have done today, we've introduced number strings, booleans, and images.
Yep.
For number
Yep.
strings and booleans, they are like cash. If you're lost in a city, but you have cash, you can probably get what you need. If you have a piece
Mm-hmm.
of information that you want to encode, you'll probably need one or more of number strings or booleans. Right.
Mhm.
I like to end my sessions by asking the student, what is one thing you learned today that stuck with you?
Oh, yeah, about the strings and yeah, it's good to learn about strings because I'm admittedly not very familiar with it. And being able to do images like this is pretty cool.
Cool, cool.
Yeah.
Okay, I'll end it right here. Well, thank you for coming, and I'm very happy to be able to help you on your journey to learning programming, and I hope to see you again.
All right. Thank you
All
very
right,
much for your time.
bye-bye.
All right. Okay.